Let's say we have two functions, f of t and g of t, for t is greater than equals to 0, and we want to look at what's the convolution between these two. So the symbol is like this of convolution, asterisk and g of t, f of t, convolution g of t, and this one is equal to integration of 0 from 0 to t, f of tau. Tau is a dummy variable which is essentially the function here, and then g of t minus tau, t tau. So this is the function itself, and for the other one it's negative g, so it's reversed and then shifted by t, and then the integration. That's what convolution is. So if we say our f of t is t and g of t is sine of t, we want to find the convolution of f of t and g of t. So that will be like this: f of t, g of t, 0 to t, this is tau, so that will be just tau, and then sine of t minus tau, which is gt is sine, as it is sine tau, so t tau. Now these are this is a product of two functions, so we have to use integration by parts. If we recall, that is like this: u dv is equal to uv minus v du. That's what we do. So v, let's say v is u dv, let's say u is, so this is u is t, so du will be actually it's tau, because we are doing in terms of tau, so we'll write tau here. The u will be 1, and dv is sine t minus tau, so v will be integration of that. Now sine integration is cos, but there is negative tau. Sine integration is negative cos, sorry, but this is negative tau, t minus tau, so it becomes plus tau, so plus cos t minus tau, because this negative with the sine integration negatives cos, they get multiplied, so it becomes plus. So yeah, so this is our integration. I will just write the right hand side. The integration is u is tau and dv is sine t minus tau. Integration by parts. I made one video before, one or couple, I don't remember, about integration by parts, so I'm just writing it directly. So yeah, uv here is u is tau and v is cos t minus tau, so that t over 0, and then minus this one v d tau, so v is of course cos d tau and du is 1, so cos t minus tau, and then 0 to t. So this is becoming tau, I'm just writing it, sorry, I'm writing it again, cos times, basically it's times, I don't need to give any sign, just so tau times cos of t minus tau, and then this is t over 0, and then this one, once integration cos t minus tau, when it's integrated it's sine t minus tau, so and the negative sign remains there, so sine t minus tau, and then this is t 0, so this one t and then cos of t minus t minus 0 times cos of whatever t minus 0, and this one, for this one it will be sine t minus t, and then plus sine t minus 0, basically. Actually this one as well, when because there is a negative tau, sorry, so that one becomes plus, because that negative tau's minus 1 comes ahead of it, so it becomes plus. This sign changes, and cos tau or cos whatever, when integrated it's just sine tau. So this is plus here, so this one is plus and this one is negative. Okay, so that's there. Now if now this one is t, so I will look at the first term, t times cos t minus t is 0, so cos 0 is 1, so that's t, the first term. Second term becomes 0 because this is 0 times cos 0 cos t, but 0 times cos 0 cos t, so this is becoming 0, getting cancelled. And this one is sine, the third one, sine t minus t. I'm looking at this one, sine t minus t is sine 0, which is 0, minus sine t. So yeah, sine t minus 0, so that's sine t. So t minus sine t, that's what remains. These two terms, they become 0. So this is our convolution, the result of the convolution. So we have a tedious integration that we have to do when we want to find the convolution of two functions. But in the next video I will talk about convolution theorem, where we will see if we use Laplace transformation we can do away with the integration. So yeah, maybe in the next video. So yeah, it's just an example of convolution basically.